Okay, this is the review for test 5, and we will get started here. At the beginning, you're going to just find an f of g of a number or g of f of a number. So in this case, we have g of f of 2. So we always start on the inside, f of 2. So I'm going to find f of 2. So I'm going to f, which is 6x. So x is now 2 plus 7. And working that out, 12 plus 7. 12 plus 7 equals 19. So that's the answer to f of 2. So 19 can replace f of 2, leaving us g of 19. So whatever you get as the first answer always goes into x in your second function. So now we're going to g. 3x, so 19 minus 2. 3 times 19 is 57, minus 2, and that is 55. Letter B. G of negative 3 is on the inside, so that's where I'm starting. G is 3 times x minus 2. 3 times negative 3, negative 9 minus 2. That is negative 11. That is the answer that is now going to get plugged into the outer function of f. So f of negative 11. And f is 6x plus 7. So negative 66 plus 7. And that simplifies to a negative 59. Letter C, where there is still an x in there. So g of x is the beginning, and that equals 3x, and x is replacing x, so it doesn't change. 3x minus 2, and g of x is this thing is now going into f, because you can't simplify 3x minus 2. There's an x in there. So f is 6. What's our new x? It's this, 3x minus 2, put that in parentheses, plus 7. And you have to distribute because there's parentheses. 6 times 3x, 18x. 6 times negative 2, negative 12. And then you have that plus 7 out there. And these two can be combined. So you get 18x minus 5 as your final solution. All right, moving on to D. We're now going to be doing performing operations on some functions. Here we're going to be using addition, here's subtraction, and here is multiplication. So g of x, I'm just rewriting what g of x is, 3x minus 2, and we're adding f of x. F of x is 6x plus 7. It's always helpful to put them in parentheses, especially when you get to subtraction. There'll be some sign changes that occur. When you're adding, everything can just be combined that are like, of course. So 3x plus 6x is 9x, and then you have a negative 2 plus 7 is positive 5. So 9x plus 5 in 1 or 2 steps there. Very quick and simple. Now we're at subtraction, so I'll show you what I mean. F of x was 6x plus 7. I'm subtracting g of x, 3x minus 2. Now there's subtraction here. You'd have to distribute that, but what I like to do is change that to addition. So you'd have 6x plus 7 plus, now you have to change the sign of everything after it. So it's a negative 3x, and that becomes positive 2. So now you can look at like terms, 6x and negative 3, positive 3x, Positive 7 and positive 2 is positive 9. 3x plus 9. Letter F. We're multiplying. G of x is 3x minus 2 times, so I just put it next to it, f of x, 6x plus 7. Now you'll have to do the FOIL or the box method. I will show the box method. So 3x minus 2, and then we have 6x positive 7. All right, 6x times 3x is 18x squared. 6x times negative 2, negative 12x. 3x times 7, 21x. 7 times negative 2, negative 14. So putting all that together, you have 18x squared. These two can be added or combined. 21 plus a negative 12 leaves you positive 9 x's, and then you have a minus 14 on the end there, and that's the final answer there. All right, we're going to work with some new functions here. We're going to have a different f of x and a different g of x than we did up here. And we're still multiplying just as we did right here. F of x, 4x to the 2/3 times g of x, 2x to the negative 1/2. Now when they look like this, you're just going to take the coefficients and multiply them together. So 4 times 2 is 8. And this is on the calculator. When you multiply like bases, we have an x and an x. When you're multiplying, you add the exponents. So I'm going to add two fractions together here. 2/3, I'm going to add to it a negative 1 over 2. And I get 1 over 6. Now that's my new exponent. So 8x to the 1 over 6. And that is the final answer there. So it's not difficult with use of the calculator there. Now we are dividing. So you can put it as a fraction. F of x is on top. 4x to the 2/3 divided by g of x, which is 2x to the negative 1/2. All right, again, just as we did here, you looked at the whole numbers, the coefficients, the same thing in this process, except we're dividing. 4 divided by 2 is 2. So if it was 2 over 4, we'd have 1 over 2. You just simplify it. If you need to keep it as a fraction, keep it as a fraction. So now we have like bases, but dividing, and when you divide, you subtract the exponents. So I'm now going to subtract these two fractions. Let me clear all this out of here. 2 over 3, and I'm subtracting. This is already a negative, so make sure you don't lose that. So you have 2/3 minus a negative fraction, and we get 7 over 6. So 2x to the 7 over 6 is the answer. So those aren't that difficult. There's really just one step involved if you know how to tackle it. Okay, number 3. If f of x equals 3x minus 1 and g of x equals 2x plus 7, what is the difference? So we know we're going to be subtracting between f of 6 and g of 2. So first I need to figure out f of 6. So I'm going up to f, 3x, so 3 times 6 minus 1, and that gives me 18 minus 1, which is 17. So f of 6 equals 17. Now I'm not plugging that into the next one. I just needed to know f of 6. That's 17. I also need to know g of 2. So now I'm going to do that separately. G of 2. G is right here. 2x, so it is 2. 2 times 2 plus 7. and 2 times 2 is 4, and that equals 11, g of 2. And we want to now find the difference between f of 6 and g of 2. So we're going to find the difference between 17 and 11. So 17 minus 11 equals 6. So it's just worded kind of different, but that's a pretty simple process there. Number 4. Now we're going to do a composition. This is called a composition when it's a g of f of x or f of g of x. So starting with the inside, f of x, that equals 3x minus 2. And remember when we had x, you can't simplify this, so that is our answer going into then g. So g of 3x minus 2. Instead of getting a number here, I just leave it with the x's. Going to g, it's x squared. This is our x, so it's 3x minus 2 squared. Now there's one like this on the test, so I do not want you to distribute that 2 into there. That's a no-no with this operation in the middle. So anything to the second power simply means you multiply it by itself, or you multiply it twice. 3x minus 2 times 3x minus 2. So this might be another box method. 3x minus 2, 3x minus 2. You can use FOIL. I'm just showing the box method. 3x times 3x is 9x squared. 3 times 3 is 9, and there are 2 x's. 3x times negative 2 is negative 6x. 3x times negative 2 is also negative 6x. And a negative 2 times negative 2 is positive 4. So you can usually combine those two if they are like, and they are. So that is our highest degree. So our answer is 9x squared. Those combine, they don't cancel. Negative 6 plus negative 6, negative 12x. And then you have this positive 4 on the end there. And that is the answer to that composition. All right, we are on to the back. And number 5, we're finding the inverses for all 5 of these. Got a little blurry on me here. Okay. Y equals 11x minus 5. I'm just going to flip this. So y becomes x. And x becomes y. And now we're solving for y, remember? So I need to remove everything around it, starting with anything added or subtracted. So I need to add 5 to both sides. So I get x plus 5 equals 11y. And now I need to divide by that 11. So your answer could be x plus 5 over 11. Or, remember on the test, especially if it's multiple choice and you don't see an answer that looks like that, you can split them into individual fractions. So remember there's a 1 in front of any variable that does not have a number. So it's 1 over 11, and there's an x there. So you put it next to it, or it could go on top. And then this would get its own fraction. Positive 5 over 11 equals y. So either of these would be acceptable. But just know on the test, if it looks like that, it is the same thing. Letter B. I'm going to swap out the y and x. Y is now x. X is now y. I need to remove that 11 first. X minus 11 equals negative 4 over 5 y. Now I saw in the homework, and I went over, a lot of kids were dividing by a fraction, and that gets really messy when you have a fraction in a fraction. So the other way to remove a fraction when it's next to a variable is you can multiply by its reciprocal. So I'm going to put negative 5/4 on both sides. And I'm going to put that in parentheses to remind me I need to do the distributive property. So the negative 4/5 and the negative 5/4 will cancel, leaving us with y equals, if you were to multiply those two together, you'd get 1. So there's like a 1y. That's why they cancel. So now I'm going to distribute. Negative 5/4 times x is just a negative 5/4x. And now times the negative 11. So negative times a negative is going to be positive. 5 times 11. And you can do this on the calculator. I'll show you how to do that actually. So we have a fraction of negative 5/4 times negative 11. And we get 55/4. And there you go. This one is more in line with this one right here where you have the fractions split. Most likely the way you would see it on the test. Letter C, swapping the letters, x equals negative 12y plus 7. We're getting the inverse here, that's why we're switching x and y. We need to get rid of that 7. So x minus 7 equals negative 12y. Now we have to get rid of that negative 12. So again, I'm going to split it into the two fractions here. So we have y equals, so there's a 1 over negative 12. So negative 1/12, doesn't matter where you put the negative. The x is next to it. Remember, there's a 1 there. And now negative 7 over negative 12 will be positive 7/12. Negative divided by a negative is positive. And that is the final answer there. Letter D. So this was the bottom of 5.2, the power functions. So f of x just means y. And now I'm swapping the two letters. So x equals y to the 7th. And to undo a power, you use the radical. Take a root. So 7th power and 7th root are inverses. So I'm going to take the 7th root of both sides. And 7th root and 7th power cancel. So y equals, and you can't do anything with that. So it's just the 7th root of x. I think that was just like one of the homework problems. All right, so that's all you have to do there. And I believe this might have been a homework problem as well, but it's good to see it a second time because of that 32. F of x just means y, 1/32 x to the 5th. Swap the letters. X equals 1/32 y to the 5th. So now here is a case of doing the inverse. I have a fraction, so to get rid of a fraction, you can multiply by its reciprocal. And the reciprocal of 1/32 is 32/1, or just 32. So I'm going to multiply that on both sides. 1/32 and 32 become 1. So we have y to the 5th equals 32x. Now you take the 5th root of both sides to undo that power. So that would leave us y equals the 5th root of 32x. Now a lot of you thought that was the final answer, but going back 2 or 3 units, we had to kind of do the factor tree here, or you can just check, is there a 5th root of 32? So 5th root of 32, and of course it is 2. So a 2 can come outside, remember, because we took the 5th root of 32. So 2, but we cannot take the 5th root of x, so he has to stay under the radical, and that is what your final simplified solution looks like. Okay, now the verifying step. And this is probably the worst part of this unit, just because it's kind of confusing. Remember, you want to find f of g of x should equal x and g of f of x should equal x. So you have to do 2 steps for each problem. So I'll start with f of g of x. So g of x equals, so I'm just going to rewrite it like this, 1/2 x plus 2. And so now this is getting plugged into f. So basically you're plugging each one into the other. So f is negative 2x, which is this thing, negative 1/2 x plus 2 plus 4. And here's probably where I saw the most mistakes on the homework, is this number has to get distributed into both. Now these cancel, so I think that's what the confusion was. Negative 2 times negative half is 1, so you just have 1x, but it does not cancel out for over here. You have to still remultiply it by this part. So negative 2 times 2 is negative 4, and then you have a plus 4 on the outside. So obviously the minus 4 and plus 4 cancel, leaving you with x. So we verified f of g of x. Now we have to do g of f of x. All right, f of x is on the inside. So we're going to have g of negative 2x plus 4. So this is getting plugged into g. And g is negative 1/2 x. So it's this stuff plus 2. So see, they should look different. Otherwise, I just did it twice. Again, I'm distributing that negative 1/2 and negative 1/2 times negative 2. Do it on your calculator if you have to, but you can pretty much assume these are going to cancel, leaving you with an x there, 1x. So then I have negative 1/2 times 4. Well, half of 4 is 2, and it should be negative. So negative 2, and then we have a plus 2 on the outside. Just as before, negative 2 plus 2 cancel, leaving you with x. And the last one, f of g of x. So g of x is on the inside. Like that. Okay, so we got a radical here. So that is going into f. So this one is really tricky here. We have x to the 5th. So we have this whole thing, 7x minus 2, to the 5th power, plus, that's a 2 over 7. But everything just cancels out. The 5th power and the 5th root will cancel, leaving you 7x minus 2, and then you have a plus 2 over 7. So you can't just cancel the 7's out. You got to do order of operations. So minus 2 plus 2. So you get 7x over 7. And then, of course, the 7's cancel, leaving you with x. Now we're going the other way. G of f of x. So f of x is the fraction x to the 5th plus 2 over 7. So that is getting subbed into g. So we have the 5th root of 7x. So this thing, kind of hard to write here, 7x minus 2, and that is all under a radical here. So 7x was this thing right here. Okay, so now following order of operations, the 7's will cancel. So you get 5th root x to the 5th plus 2 minus 2. I know this just seems like a lot of tedious work here. Order of operations, the plus 2 and minus 2. So you get the 5th root of x to the 5th, and then lastly, 5th power, 5th root cancel, leaving you with x. Okay, that is the review for Unit 5 test on Thursday or Friday.